Algebra 2, we're looking at lesson 1111, which is working with Venn diagrams. And there is a very important formula that you will repeatedly see in this lesson. It's going to be brought up continually. And that is the probability of event A or event B is equal to the probability of A plus the probability of B minus the probability of A and B. And the subtraction that we see here corrects for double counting, we can see. But that's the formula that you're really going to see. In general, the word or is going to indicate that we will be working with addition. You can see we're also going to have to work with some subtraction. But here is a Venn diagram, and this Venn diagram shows that there are 8 students in a class, in Mr. Martinez's class. One circle shows the volleyball club. And I'm going to highlight that circle right here. We've got all these kids right here in this circle are in volleyball. And that, by the way, we can write as event A, that a student would be in volleyball. Likewise, we also have another circle. We'll talk about that soon enough. That would be circle B. That would be everyone who's inside that second circle would be in the tennis club. A student could be in both. You can see Joe is there. And Salma is outside both circles. She doesn't belong to either club. But again, we have 8 students. So what's the probability of A being in the volleyball? Well, probability, you always have to have total people or total events down below. That's an 8. But let's see how many people are actually in volleyball club. You can count 1, 2, 3, 4, 5. As always, you should, if you are able to, reduce a fraction. But here we cannot. We'll just leave our answer as 5/8. And then our focus is going to switch over to circle B. Circle B would be the tennis club. And it's a very different circle here. You can see inside that circle there is Joe, Milan, and Donna, 3 students out of a total of 8. What's the probability that randomly selecting a kid would involve that kid being in the tennis club? Well, that's 3 out of 8. But when we're saying A and B, you have to be in the tennis club and also in the volleyball club. The word and is always going to be the overlap. And that's where those 2 circles are overlapping. And that's, right in here. So Joe is the only student who's in circle A and in circle B at the same time. So there's only 1 student that we have here out of 8. So, we have 8 students to select from. Only Joe, that 1 student, would be in both clubs. When we get to or, however, again, you can think we're going to have this over 8. When we're in or, that's going to mean either you are in this volleyball circle right here, circle A, or you're in circle B. But circle B, of course, is going to have some overlap. This blue and the yellow are making the green. So, my goodness, you're in volleyball or tennis. That's going to be anybody in circle A or circle B or both. So we've got 1, 2, 3, 4. Joe's in both. That's 5, 6, 7. It's okay to be in both. This is what we call an inclusive or. So that would be 7 out of 8. Now this formula, P of A plus P of B minus P of A minus B, you can see that we're really going to take our 3 answers here. We could get 5/8 plus 3/8 minus, well, what's the probability of them both? That's 1/8. Tell you what, let's just add our numerators. 5 plus 3 is 8. 8 minus 1 is 7. We'd get 7/8. You could use your calculator if you need to. But what are we seeing? this last answer here is really this formula that we have. They were asking you to work all this stuff out on the right-hand side. What did we see? We saw we got the same answer from what we got on the left right here. So these two are the same. So in the future, you can even more quickly cut to the chase and say, I know that this formula has to relate to the probability of A or B. And that's what they're really asking for right here. They're saying, look, what you just found, hopefully you can see it's ultimately the probability of A or B. They're going to include this feature on the problems repeatedly. You're going to see it in pretty much every Venn diagram problem. Let's keep going. This time we've got 12 students in Miss Lopez's class. We've got a science club and a volleyball club. Ahmad is outside of those circles. He doesn't belong to either club. So circle A would be the event that the student is in the science club. Circle B would be a student is in volleyball. And of course, once again, there is overlap. But remember, we've got 12 students. So I can tell you already, we've got 12 for our denominator for our probability. We've got 12 students to select from. Here is circle A. That would be being in science club. We've got 1, 2, 3, 4, 5, 6, 7, 8. Even though this is in the overlap, that's fine. Tell you what, let's divide by a 4 on top. Divide by a 4 down below, you'll get 2/3. How about the circle B? If we're to focus just on circle B, that's the volleyball club. We've got 1, 2, 3, 4, 5 students who would be in that circle. So that's 5 out of 12. You could try to divide something out from the numerator and denominator. It won't work. This is as far as we can go. You always have to simplify your fractions. Now they're going to say the probability of A or B. A or B, that means you're in the science club or you're in the volleyball club. Well, it means you're either in circle A or you're in circle B or you're in both. That means everybody who's inside one of these circles counts, including the overlap. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 kids are in one or both of them, because that or includes being able to be in both. 11 over 12, we can't reduce it any further. Now, when you get to and, however, the and is always the overlap. And guys, the overlap, you have to be in both clubs. And that overlap is right here. You can see there are only 2 kids who fit into both clubs. So that's going to be a 2 out of 12. Now 2 out of 12 will reduce to 1 over 6. Now, here's this very famous formula. That we've got right here. Okay, just had to fix moving all the text back up. But this last problem right here is really the probability of A or B. That's that big formula that we're always going to see. So tell you what, you could cut to the chase. Be my guest if you'd like. You could work out all the arithmetic. You could, if you wanted to, take 2/3 plus 5/12 minus what you just found right here. You will see that you get the same thing. And as we've been saying, it's always going to be this or. Well, so we go to our last page here. Draw 2 circles that represent A being over 5 feet 9 inches. So we've got a relatively tall person here. You're bigger than 5'9". Circle B would be being under 5'6". I hope it's clear that you can see there's no way someone could be both. No one could say, yes, I'm taller than 5'9", and I'm also under 5'6". So this is what we call mutually exclusive. The probabilities of being in both would actually be 0. By way of comparison, draw two circles that represent being over 5'9", but then having brown eyes. Well, look, it's possible to have overlap here. It's definitely possible to have overlap. It's possible that circle B having brown eyes, everybody who has brown eyes might be over 5'9". Circle B might be inside of circle A in its entirety, in fact. So this would not be mutually exclusive. Well, what are we getting at? Mutually exclusive, it's kind of like that first example. Nothing is in common. You can't meet both conditions. The probability of being in A and B at the same time would be 0. We learned the other day in the previous lesson, 11.9, that if two events are independent, recall that P of A and B would be P of A times P of B. And here is this super important formula. Wow, we're using it all the time now for these last problems. So let's wrap this up. It says A and B are two events. Probability of A is 0.18. Probability of B is 0.20. They're saying, can you find the probability of A or B? But they're telling you that A and B are mutually exclusive. What does that mean? It means you cannot meet event A and event B at the same time. It's impossible. It's kind of like being over 5'9" and less than 5'6". It can't happen at the same time. Mutually exclusive probabilities, the and here are 0. It can't happen. So plain and simply, you just add 0.18 and 0.20. And it won't take you long to do that. You're just going to be able to real quickly imagine that you're adding 18 cents and 20 cents. You'll get 38 cents, right? So from here, we're going to assume that we've got independent events. So A or B, we still have this same formula. But for independent events, we saw from the previous section that was the probability of A times the probability of B. So what you're going to have, plain and simply, is 0.18 plus 0.20 minus 0.18 times 0.20. And you're going to give an exact decimal answer here. So what we need to do is just plain and simply type in 0.18 plus 0.20 minus, well, right now we can go 0.18 times 0.20. Just let the calculator do all of that in one calculation. 0.344 is what you get, and we are done.